Hi ladies and gentlemen, I hope everyone is doing well today. Today we are taking a look at transition metals. So I just wanted to remind everyone about a couple things before we start. So you have to remember that transition metals are located in columns 3 through 12 on your periodic table. Remember transition metals, because of how much energy the d orbitals have, the charges are very difficult to predict. So today we are going to take a look at transition metals and how to predict their charges. So we start with some information on transition elements. Reminds you of a couple of things that I just said, that the charge is hard to predict. There are three exceptions. The three exceptions are right here. They are silver, zinc, and cadmium. So every transition metal can have multiple charges except for these three. Silver is always +1, zinc is always +2, cadmium is always +3. Accelerated students will have to memorize this. CP students will be given this as a list on the top of the quiz. So next you are going to write the formulas for the following compounds. So remember, these are still ionic compounds. You still have a positive reacting with a negative, so we are still using the crisscross method. So use the crisscross method, figure out the charges for question 1. So then next, the information. So it tells us that transition elements can have more than one charge when they become an ion. So to figure out their charge, we have to use what they are bonded to figure out what the charge is. It's kind of like reverse thinking. So again, it reminds you that in question 2, these are similar to the examples we had on the one Chemquest where we had X's. So remember, so we can figure out the charge of X based on what nitrogen is. So nitrogen has a -3 charge, and we know that we have 3 of whatever element X is. So that means X must be +1, because 3 times +1 is a +3. +3 would cancel out -3, and it would be neutral. Remember, we're still following ionic compound rules, so the positive ion needs to come first, and the charge still needs to be neutral. Question 3. So question 3 is a little tricky, even though that the two forms of copper chloride are different. Try to think about their names. Same with the iron sulfate. Is there any difference between the names? So next, we are looking at the information. Formulas containing Roman numerals. So what you probably noticed is that the elements copper chloride and iron sulfate had the same exact name. However, we need to specify the difference between CuCl2 and CuCl. So to specify the difference, we use Roman numerals. So the next couple questions, we're trying to figure out what the Roman numerals stand for. So question 4, what I want you to try to think about when you're thinking about this question is compare the Roman numerals to the charge of each of the transition metals. And then what do you notice about the charges and the Roman numerals? This will help you determine what the Roman numerals stand for. Next is question 5. So when you're working on question 5, remember that the Roman numeral is 4. So why is MnO2 called manganese 4 oxide? What does that 4 represent? You will have to remember that the subscripts are similar to fractions. So if you had a fraction that was 3/6, that would reduce to 1/2. Same if you had a fraction that was 2/4, it would reduce to 1/2. So remember, we use this principle with MnO2. So think about the charges and think about how it would reduce. So next, question 6. So question 6 is asking us to name the following compounds. So remember, anytime we have a transition metal from the D block, which is columns 3 through 12, you must use a Roman numeral unless the element is silver, zinc, or cadmium. You have to remember that the Roman numeral tells us the charge. So that Roman numeral is important so we know what the charge of the transition metal we are dealing with. So right now, name them the same way. So if it's a positive ion, the name doesn't change. If it's a negative ion, we drop it to "ide." Remember, you have a list of polyatomic ions, so if it's a polyatomic ion, make sure you use the correct name. Remember, you don't have to change polyatomic ions' names. And then remember, if it's a transition metal, include a Roman numeral. Question 7. So question 7 is now writing the formulas for the following compounds. So remember that the Roman numerals stand for the charge of the transition metal. So the first one was done for us is mercury 2 acetate. So we can quickly look at this because acetate CH3O2 with a -1 charge. So then if we crisscrossed, we would get the answer. It would be Hg1, which we don't have to write because it's a 1. And then the 2 is on the outside of the parentheses. Remember, the 2 needs to stay on the outside of the parentheses because this 2 is saying we have 2 acetate ions. So you need to remember all of this is multiplied by 2, not just one of them. So now while you were working, use the crisscross method. Remember the Roman numerals tell us the charge of the transition metal. Remember, if a Roman numeral is not given to you, then you should be able to figure out the charge based on the octet rule. So then lastly, question 8. So question 8, you guys can answer. Question 9. So remember when you're working on question 9 to only use Roman numerals when necessary. So we only use Roman numerals when the element is in columns 3 through 12. So do not use Roman numerals unless it's actually a transition metal. And then question 10. So question 10, you're naming the following compounds. So remember, you do not need Roman numerals for B or C. You do not need Roman numerals for B or C because they are 2 of the 3 exceptions that are on the front page. Remember, Excel left it memorized, CP will be given to you. So remember, use those charges when you are figuring out the names. And then that will also help you with question 11. So please, while you're working on this, make sure to circle any questions that you have. Write down the questions so you don't have to remember it from the video to class. Remember to bring your questions, ask me if you have them, and we'll take it from there. Have a good one.